I'm going to talk a little bit about the evolution, or as we say, the revolution around OSS and service management. How is it evolving? Why it needs to evolve? And where is it going in terms of how we have done OSS in the last 25 years? If we think about a lot of the discussions that we had in the last couple of days, there's been a lot of discussion around web-scale companies, a lot of discussion around OTT players, and so on. If you look at the common denominator for all these companies, be it an Amazon or a Netflix or a Google or whoever, we would see that all of these guys are part of the platform economy, which means they rely more on innovation of their ecosystem to be competitive than just relying on their own innovation, which is very remarkably different than what operators have typically done. With virtualization, with upcoming 5G evolution that's happening today, there is an opportunity for operators to become part of this platform economy, to become more ecosystem-centric, working with more partners. Obviously, with 5G, IoT is a huge use case, which does mean that you really have to work with other industry verticals to make more money. And as we see the evolution towards becoming a digital service providers, becoming part of this economy obviously have to be, it's not a matter of choice anymore. You have to be part of this. Now, when we look at virtualization, right, we see a few things. And as part of some of the deployments that we are doing across the globe with some of the largest carriers in the world, we see a few things. In the last few years, we have seen technology per se not being a huge barrier. Let me clarify what that means. I mean, whether a VNF works, whether you can upload that into a marketplace, whether you can do some of those things or do a service chain, is that possible? Is it scalable enough? Can you provide the same amount of SLA guarantees for enterprise customer when you do that? Those things are achievable today. We have seen that with many of our customers. Now, the path to that might not be as smooth as we would like it to be, but it is possible. Monetization strategies, pretty clear. It's very common. If you look at across the different levels of operators that we're working with, be it the DT Cloud CP PanNet program that we are running, or the Vodafone Ocean program that we are working with, or even the Etisalat or NTT Docomo, whoever, enterprise. And so you pointed that out. Enterprise, be it the small, medium-sized enterprise or the big, large enterprises, that's a major focus. So the strategies pretty much are there. Org structures, we have seen that changing as well. The successful operators, the operators who have gone live with certain services on virtualization, they have architected changes in their organizational structure. They have created the satellite teams. They have created the right processes in place in order to make it happen. So all of these things, which were really the initial bottlenecks when we started off 2012-13 with SDN and FV, to some extent, there's a long way to go, but to some extent has been resolved. However, in order to become a long-term player and to become really successful in the platform economy, as well as to roll out services that they would like to, in terms of how, in comparison to how you would roll out services in weeks and days, rather than in months and years that operators are used to, we need to look at operational excellence. Now let's look at where we are, right? I mean, we have been in the industry for a long time. Traditional OSS needs to evolve. Being in this business for 25 years, so we know this better than many of the others. Traditional OSS supported operational processes, which were semi-automated and in many cases, very, very manual. Resource inventory typically got replicated across your different siloed vertical stack. It was statistically bound to services were bound to individual resources, and obviously required detailed offline design before you roll out the services. Every new network, every new device, every new patch required some level of change request. Because now you are changing, you're upgrading, you're changing the configuration, you're doing some of those things. Also, a lot of times, the resources or the diverse set of service-unaware resources used to be part of the system. Which means what? Network inventory typically used to be offline. And that's how it used to be. That's how it has been for many operators in the room. That still is the case. And discovery and reconciliation does that once a day, once a week, whatever that might be, in order to make sure that the stranded resources are reconciled to some extent. Now, with an on-demand network that we're talking about with virtualization, where we can on-demand use VNFs to scale in, to scale out, to create a different type of network environment. Or with 5G, for example, where we're talking about on-demand network slicing, this model doesn't really work very well. Now, one way, a simple way to do this is, okay, we have siloed stacks, and let me create a God or a very big orchestrator stacks, which will tie in all of these things together. Perfect business for us. We would love it. Because that means that will be more change requests, more services, and we do services for operators, and that will be perfect for us. Long-term strategy, 5 to 10 years, managed services, fantastic. We love it. But that's not how or that's not the way to get into the next level of service excellence that we are talking about. So if we look at what needs to happen in an operations environment, there are certain fundamental things that we need to keep in mind. And these are critical, right? Now, before I get to that, sorry, I missed one. We talked about legacy problems, right? But with SDN and NFV, so for example, with SDN controllers and with all the Vim managers and NFVMs and all of that stuff that the operators, the vendors are talking about, apparently, or it was touted that these will be mainly automated. SDN controllers will automate things, the traffic queuing will be automated, NFV, with all the VNFs, it will be automated. But the fact is, if you talk to any operator in the room here today, it's not. It has just compounded the problem that OSS has already had, bringing these kind of different things. Think about onboarding. Think about license management. Think about the descriptors. Every network equipment vendor has a different flavor to it. And if you look at open source, and if you look at ONAP and any of the other initiatives going on, multiple streams going on in these things to fix it. So again, more of a spaghetti than it used to be in the past. So in this is, if it's the order of the day today, and this is going to grow because let's say physical network resources are going to, or the PNF functions are going to be decreased, and we are going to increase more SDN NFV stuff, or VNFs, and SDN controllers, this complexity is going to exponentially increase. So in that context, if we look at the requirements to achieve operational excellence, what are really those, right? Managing hyperconvergence becomes very, very critical. So it's not just about your switches and network functions anymore. It's about your cloud stack. It's your IT stack. It's your applications. It's your VNFs. It's your IoT applications. You name it, right? Data modeling. I think it's been, a lot of people talked about data modeling. Again, I wish it was as simple as some of the people presented before, this data modeling. I really, really wish. But it's not. It's not. If you ask an operator, they will tell you what's the difference between a startup is and what a company which is 25 years in the business is, and why it is not that simple. Because they do it on a day-to-day basis, and it is not. It's very, very complex. Distributed, right? We talk about OSS being centralized. That's how we have always done it. Now we are talking about edge cloud. Now we are talking about mobile edge computing. We are talking about technological as well as geographically dispersed services and resources. How does your OSS manage such an incredibly complex system or an ecosystem? Real time is a must. We talked about inventory being offline. It used to be. But with SDN NFV and with the on-demand network resource functions and so on, we need to be able to manage the changes in real time. Dynamic topology changes need to be incorporated. Need to make sure what resources are in your network inventory at any point of time. So the real-time nature of inventory is a huge shift from where we had in the past with network inventory to where we are going today or where we are at right at this point. Closed-loop control. Policy becomes important. So you talked about that. It is a crucial thing when we talk about a closed-loop kind of an environment. Because it's not about, I have fulfillment, and I'm going to bring an assurance. That doesn't work. Because we are talking about VNF functions. We are talking about mixing PNF and VNS. We are talking about cloud. We are talking about applications. The moment you fulfill a service, the moment you chain a service, the moment you deploy a service, you start measuring the resources. You need to figure out at what point you need to scale out, at what point I need to bring in different functions, at what point I need to bring in bandwidth. So the lines which always existed between a fulfillment and an assurance tends to blur. The importance of machine learning, importance of AI, importance of analytics becomes more and more profound because now you have to anticipate. How is my resource that I have now at 90% going to change in the next 50 minutes or next 15 minutes or 10 minutes or whatever that might be? depending on the potential orders that might be coming in. How do I manage the exigencies looking into the future? Because once you have a disruption in service, your customer doesn't care, right? Whether it's because it was on a VNF, hence the service failed. If I was Skype and I'm an OTT player, that's fine. We are used to the world of that. OTT players, there's no service guarantee. It fails most of the time. It doesn't matter. Not for the operators. So your OSS is not just about managing these, but also managing some of these functions. So policy, control loop, fulfillment assurance coming together, all of your FCAPs coming together, all of these becomes very critical. And now when we talk about a distributed environment, your OSS or your service management, whatever we call it, cannot be on-premise, cannot be tightly coupled, cannot be deployed only at your central office or wherever. It needs to be cloud native. It needs to be containerized. We should be able to deploy that with full resiliency and availability and active mode in any location of choice. So if we keep that in mind, we see there is a major impact. And if we look at the traditional networks and the way we have done fulfillment, assurance, and as well as support and readiness, that changes. But that doesn't mean that the components that we have used in order to manage those network and changes. We still need those things. We still need a resource catalog. We still need an SDN control management. We need a multi-layer path compute. We need lifecycle management. We still need to activate. We still need to do measurement. We need to do SLA management. So what it becomes is the new orchestration environment that combines functions across all of these different vertical stacks. And if you think about this as your domain management capability, these are your subdomains, which brings together certain componentized-based functions that are absolutely critical, whether you talk about your traditional networks or you're talking about SDN or whether you're talking about NFV. So this brings it to the concept of domain orchestration. So what is it? What is really a domain, right? So a domain is a self-sufficient, I would say a self-sufficient kind of a container which includes relevant components of the new orchestration environment. So from an activation to an assurance to your FCAPS capability. And to describe it, what could be a domain? It could be a resource. It could be a service. It could be a geography. Depends on how you look at a particular domain. So an IP optical could be a domain. A voice over LTE service could be a domain. We recently launched our 5G monetization solution. In that case, the domain orchestration enables some of these 5G components, such as mobile edge cloud, for example, cloud CRAN, for example, which becomes part of domain orchestration. However, the attributes are very important, right? It's open APIs, it's fully programmable, it needs to be cloud native, it needs to be self-sufficient. So which means that these are self-contained functional elements which does all these FCAPs to activation, all of those in its own way. So let's take a look at what that really means, right? So if you think about a virtual CPE, right? And you remember the subdomain components that we talked about, you can include some of these things that you can bring together in order to create a virtual CPE service. So for example, you don't have to reinvent the wheel. You don't need resource inventory for every single time you're rolling out services. You have the resource inventory. You bring out the right image of that in order to make this for a virtual CPU. You need license management, you need the FCAPs, you need config management, you need activation. Some of the same elements will be used. Let's say we pick a transport, for example, right? The resource inventory still remains, right? Because resource inventory you need for either virtual CPE or a transport. However, for a transport, you need a path computation because you're now doing a multi-layer path compute, which you probably did not need in a virtual CPE type of situation. So you bring in the components that you need, and you create the domains which works with each other. So now, if we look at the domains in this construct, this is the view that you go to, which is every single domain has your operation support readiness functions, your design, assign, your planning, your fulfillment in terms of the resource assignment, your activation, et cetera, as well as your SQM, SLA management, and some of your assurance functionality in a closed loop type of environment. It is a pure, and if you think about it, it's more like an intent-driven, right? So I have an SD-WAN solution that is, closed loop. It works on its own, and it does its own function. And it could be from different resources, because remember, the resource layer is across all the different components that's out there. Based on the intent, based on whether it needs something else, it calls out, and some other domain orchestrator gets invoked. It's nothing very different than how an Android app works today. If you have a restaurant app, for example, and you're looking at a restaurant and all of that, and then you now say that I want to look at the map of that. It's an intent that I'm calling out for a map, the app calls out for a map, the map gives up. The map doesn't know what the user is doing. It's a question of how does one app call another sub-app and move that along. It's a similar construct. Now, each of these are microservices-based, container-based. You can now use that or deploy that in any parts, so whether it's in your data center, you want to do that in a private cloud, if you want to do that in a public cloud, it's up to the operators. There are certain operators that we are working with in some of these constructs. They're moving away from the way they have traditionally done OSS in the last many years. So again, self-encompassing. It does the FCAPS function. It works with each other in a peer-to-peer way, and obviously it will call out for resources it needs as and when it needs it. So a very simple example, right? So I'll give you one example. I have 3 minutes, that's perfect. Let's look at a transport domain example, right? In the traditional world, if I'm talking about a transport, right, I will have a traditional OSS system. It will work with an NMS, with FCAPS for IP MPLS and optical. I'm just taking IP MPLS and optical at this point, right? So it will do the provisioning there. I now deploy an SDN controller. So I have two, one for IP MPLS SDN controller and an optical SDN controller, right, on the control plane. The dynamic multi-layer SDN controller, right, works with these to create the optimal paths between some of those. And I have an end-to-end SO or a service orchestrator, which will now work with the traditional OS system and stitch it together with a multi-layer SDN controller. Lovely architecture, we loved it. We always have done it in similar fashions. I'm simplifying it. Obviously, if I get to the architecture, it's a lot more complex. But with a domain orchestrator, this changes very drastically. Domain orchestrator, you bring together your transport domain orchestrator, which does its own FCAPS functionality, which does its cross-domain or path compute, and calls in the other two, which is your IP MPLS domain orchestrator and your optical domain orchestrator. Now, you can add a microwave on top of it if you think that that's what it is, and that will become another huge queue on this OSS side, because you're going to go another branch and another level of complexity. Here, you're going to bring in a microwave domain orchestrator, for example. And then on top of that, if you want to roll out new services, you go ahead and you add more and more domain orchestrator. So it becomes branching, it becomes work with each other, and it obviously expands as we go along. But these are reusable components. Now, what that also means that operators can bring these domain orchestrators from different vendors. Transport can be from a vendor X, IP MPLS domain orchestrator can be vendor Y, because they are all based on intent. Ideally, it should be able to work with each other, but we all know that ideal situation never happens, which does mean that there will be some work to get it done, but it gives operators options. They don't have to rely on one particular vendor, one particular network equipment vendor. They can distribute that and bring together the best pieces from different pieces and fits in all together. So a sea of change, a major change in the way we have done orchestration, we have managed OSS in the past. It takes a whole different dimension. It gives a whole different level of scalability, as also control to the operators. So vendor lock-in goes away, and it brings in two important components. One is from a top-down standpoint, automation, which is self-service driven approach, which is I order a service, it decomposes, it breaks down, and so on and so forth. That's one level of automation. It also takes care of automation from bottoms up, which means I introduce new devices, I introduce new VNFs. Intelligence across these should be able to adapt to this and manage that much more effectively. So that's in a quick nutshell as what we are trying to do. This is something we are approaching with, we are doing with some of our really large tier 0, tier 1 customers. I think this is the next change and evolution of where we're going to see around service management. Thank you.
Thanks very much, Ari. Great example of simplification.